Wonderful. Just at 4:01. Welcome everyone to our 13th Just in Time session for topic number 13, which is our second last session. We're going to have one more on consolidation, but this is our last topical session. And we're going to start with our territorial acknowledgement. You know, data that's presented sometimes from the right angle can give us powerful perspective. I want you to take a moment, if you haven't had the chance yet, to look at this image and reflect. I'll give you just about a moment to do that. You know, in Canada, we have a deep and a dark legacy, one that has been quite hidden in our history and swept away. In this statistic, we see that a World War II veteran had slightly better odds of surviving than an Indigenous child in residential schools in Canada. Now, this isn't some far-off distant sectarian regime, you know, hundreds of years ago. This is our current legacy, and this is Canada. I want you to take a moment and listen to some of the voices that have experienced some residential schools in Canada.
I got frightened when I was a little girl when the principal used to beat up the other children, like boys. The boys got the most beating. They used to call it bench party, and it was usually done after supper. And that's where I got frightened, because I saw blood.
I remember when we had to shower. You know, you only have to show me how to shower and clean and wash myself, how to wash my private and my, you know, private parts of your body. You only have to show a kid once or twice at the most, but not every day. You know, and have the supervisor come in there and basically take advantage of you, you know.
I just remember arriving there and donning new clothes and, of course, getting a haircut and sitting in a classroom and being with other girls and witnessing my brother get punched by the supervisor.
My name is Alice Little Deer. I'm 78 years old. I spent about 8 years in residential school.
My name is Raymond Mason. I'm 62 years old, and I attended residential school for 12 years.
I'm Madeline Dion Stout. I'm 62 years old. I'm from the Kihiwan First Nation in Alberta. I attended Blue Quills Residential School for 36 consecutive months. That would be 3 years.
In order to educate the children properly, we must separate them from their families. Some people may say that this is hard, but if we want to civilize them, we must do that. A federal cabinet minister, 1883.
Hebron, you're muted.
Thank you. With this in mind, we'd like to begin by acknowledging that the land on which we gather today is the land traditionally used by the Haudenosaunee, Anishinaabe, and Neutral people. We also acknowledge the enduring presence and deep traditional knowledge, laws, and philosophies of the Indigenous people with whom we share this land today. So, for our agenda today, we're going to talk about some of the topic timing to finish off the year. We're going to look at the LRP site and data and probability across the grades. We're going to do some math talks. We're going to talk about measures of central tendency, which is mean, median, mode, misleading graphs, and probability. So that's our plan for today. As we usually do, we would love to get your feedback on where you are at right now in terms of what topic your class is addressing. If you could pop that into the multiple choice pair deck, that would be fantastic. Gives us more data to work with as we continue to our consolidation, I suppose, in a couple of weeks. So I'll give you a minute to do that. This is what the rest of the year looks like for May and June for our math topics. So we are just finishing up, entering topic 12, entering into data and probability. We're going to have some time for you to engage with consolidation before reports are due and afterwards. And we're going to give you some tips on June 1st, I believe. Our next just-in-time session will be on some ideas to engage students, but also strategies on how to consolidate some of the things that you have addressed throughout the year. So that's our topic timing in one glance for May and June. Let's jump into our current topic 13, which is data and probability, which is one of my favorite topics. There's two areas that we've broken down this topic into. One is data analysis, where we will be looking at really two ideas. One is those central tendency, mean, median, mode, and then the other is making convincing arguments from graphs and dealing with misleading graphs. And then, of course, we're going to look at probability, theoretical, experimental, and then descriptive in grade 4. We're going to be focusing more on descriptive words around probability. So this is that continuum that we usually jump to. And this continuum digs back into grade 3 a little bit. So when we look at data analysis, grade 3 students are dealing with mean and mode, no median, and they're dealing with whole numbers for central tendency. That moves to mean, median, mode, and whole numbers in grade 4. And then in grade 5, they're dealing with mean, median, mode, including decimal numbers. And then in grade 6, it gets interesting. They're comparing two sets of data. So they're using these central tendency measures, mean, median, mode, and range this time. Grade 6 has it. And then they're comparing two sets of data using these central tendency measures. Making convincing arguments is something that is pulled and continued from grade 3 onto grade 4. They're using specific types of graphs, focusing on those graphs, frequency tables and graphs in grade 3, grade 4, stem and leaf plots and multiple bar graphs, and then moving into stacked bar graphs. And in grade 6, histograms and broken line graphs. One thing we notice in 5 and 6 is that when we're dealing with making convincing arguments, we're dealing with how graphs can be misleading or how they can be kind of skewed to show a biased perspective. In probability, in grade 3 and in grade 4, students are dealing with likelihood of events. So in grade 3, they use those languages, something is impossible, unlikely, equally likely. And it's qualitative kind of descriptive of different events, likelihood of it. There's also this piece that's relatively new, that's where they're comparing probability across populations. And connecting a little bit to that central tendency they've worked with, mean and mode, in those comparisons of two different populations. An example we have here to kind of wrap our head around it is BC to Ontario. So you might look at what's the likelihood of an avalanche happening in BC versus Ontario. Well, Ontario, no mountains. BC, mountains, avalanche. So the students are using their logic of what they know about Ontario and BC to kind of compare those populations. And that content kind of continues into grade 4. So grade 4 and grade 3 don't have a lot of variation, just that grade 4, they're representing the likelihood of events in a line. So in a probability line from impossible to certain. And then in that comparing probability across populations, the two populations we looked at, they're including mean, median, and mode. So that continues. Now in grade 5, there's a shift they're looking at fractions representing probability in terms of a probability line that has fractions. And then this idea of theoretical versus experimental, which we're going to talk about and experience later in this session, comes up in grade 5. And in grade 6, that extends from fractions to decimals and percents, representing that the probability of the likelihood of an event on that probability line. And theoretical versus experimental is there, except now we're looking at two independent events and comparing. So there's that connection to that central tendency in grade 6 that, you're comparing two sets of data, the mean, median, mode, and range. Now we're comparing two independent events. What's the likelihood of these two independent events as it relates to also theoretical versus experimental? So that is a quick overview of topic 13, continuum. And now I'm going to pass it on to Heidi.
Well, good afternoon. Nice to see all of you. Let's take a look at this slide. What's going on? What do you see that makes you say, what do you see that makes you say that? If you wouldn't mind dropping your answers in the Pear Deck, that would be fantastic. I'm going to give you a few minutes to think about that.
For those of you that maybe haven't found the Pear Deck yet, in the chat, there's a link to the Pear Deck where you can see the same thing that is being presented, and you can type in your response to this particular prompt.
I like that one bit. I think they disappeared. I'm like, oh, I really like that. And then it went away. The totals adding up.
I like that somebody feels they need more information.
Mm-hmm.
I'm just reading the comments in the chat about PD on reporting. I think it's because on the Just in Time website, it said the next session was tonight, but then it said something about consolidated 1 mark or something like that. So
Oh,
The
okay.
button.
Okay, so they
Yeah,
said
I figured it out. I sent her the link to the January one, and I said I don't think they're doing a term 2 one. So hopefully that's right.
that is. Thank you, Emily. And thank you, Wendy.
It was a little hard to find the link because it wasn't on the regular math PD site. So I had to like go back in the math elementary group to find the link.
This link?
No, the one from the recording from the one in January about the one math mark. It was a little tricky to find.
Okay, it is on the Just in Time website, but it's a separate page. You have to go to resources, which is why we gave that button.
Okay, thank you. Are we ready for the next slide now? I think we had some time to share our answers. Awesome. Okay, so does this confirm what you were thinking? Does this challenge what you were thinking? When you take a look at what's up on the graph here, is this what you had expected? Okay, thank you. Do we want to go to the next slide now?
Yep.
Okay, thank you. Okay, so if you take a look at the slide that's in front of you, you're going to see that there, you can predict the categories for A, B, C, and D. So now what I'd like you to do is take a minute and go back into the Pear Deck and do that. I'd like you to predict what you think A, B, C, and D are. Okay, I think we've had enough time, or maybe
Let's see some of the responses.
Yeah, please.
Ooh.
Oh. Where's the pale orange sector mean? Could they be other visible minorities? Good questions. I like that.
On to the next.
On to the next.
A little bit more.
Okay. So does, give me 1 second, please.
So whoever hypothesized about the other minority groups, it looks like that's been confirmed.
Perfect. So does this challenge what you were thinking? Does it confirm what you were thinking? Thank you. Okay. So this graph shows who is racially profiled in these sectors. What does this leave you wondering? What else do you want to know? What are you curious about when you look at these colors, these numbers? When we take a look a little bit closer at who and who's being racially profiled and what sectors they're in.
So does anybody want to unmute or throw in the chat? Like what questions does this leave you with now that you've seen all of the data? Who collected it? Yeah.
Anything else? Okay.
Does anything seem off in terms of the numbers for people? Because I think when we first experienced this, we're like, wait a second.
Yeah. So they may not be able to read the fine print there, Hebron.
Oh, yeah.
Explain
I wonder.
what we were confused about.
I don't
wonder if-
understand what the numbers at the bottom are really. I don't really understand. Like, are they percentages? And if they're percentages, why do they go over 100? I'm very perplexed about this graph. That's why I'm just saying nothing.
Exactly. You should have. Yeah, that's exactly where we were.
So is somebody going to explain then the
No,
percents?
I think we just leave it and walk away. No, I'm just. Oh, these are good questions from Rebecca too. We're in Ontario. Let's look different. So the numbers. Does somebody want to speak to that?
You go ahead, Hebron, because that was your original question.
Yeah. So when we were looking at this, there is a little disclaimer that I'm floating over, so I have to wait for it to disappear, unfortunately, when I'm sharing. Okay. There's a note on the bottom. It says, percentages are based on the total number of people identifying with this racial, ethnic, or creed category who answered this question. Percent totals exceed 100 due to survey respondents identifying with multiple sectors, and percent reflects the survey respondents only. So this is why you have more than 100, even though these are percent values.
And I also wondered when I looked at it, like why there were no whites, like why white wasn't a category. But as Hebron just read, it was the survey respondents. And so I'm not sure how the sample was chosen, but it did not include any respondents who identified as white. Any other reflections about that before we move on? Yeah, that's true, Wendy. That could be the case. Yes, Mintu.
Thank you. All right. So meaningful data is intentional choice, and making intentional choice of a social justice issue, we need to think about focusing and provoking student thinking to make convincing arguments, opportunities to extend conversation into other areas, into language, into social studies. But when we're having students analyze data, that's a wonderful opportunity to integrate other areas as well in social studies and language arts, but we have to make sure that we remember that this is a sensitive topic, and we want to be aware that our students, while we're doing this and having these conversations with the students. Perfect. So we just want to remember that in grade 4, we want to reinforce the multiplication and division of whole numbers. What we just modeled, the slow reveal graphs, making convincing arguments. In grade 5, the slow reveal graphs make convincing arguments representing probabilities of events as fractions. And in grade 6, reinforce relationships among fractions, decimals, and percents, probability in that probability context, giving measures of central tendency, which might, what might the data set be? Thank you, Hebron.
Okay, so I'm going to take over now. And this is another opportunity for you to enter text on the Pear Deck slide. So we're going to ask you, just looking at this slide, what do you notice? What do you wonder? Of course, in the context of this session, you probably have some clues.
You let me know when you want me to reveal.
Okay, thanks, Hebron.
Mm-hmm.
And again, we encourage all of you to participate by joining that Pear Deck and jotting down your thoughts. What do you notice? What do you wonder? And can you hover Hebron so I can see? Okay, let's have a look at what we've got so far. Hey, somebody's noticing 10 frames.
Okay.
Cubes are growing. Is it a pattern? What information is being collected? Somebody else is noticing that idea of 10 frame and using 5 as a base model. What is the lowest or highest possible number? So, and then a couple more. Is this not a pattern challenge? Does this follow a pattern?
Ooh, I could fit more. on the
Wondering
screen.
when they look at it, they're making the connection to 10 frames, anchors of 5 and 10. They're making connection to a possible pattern. Is it an algebraic pattern? Okay, so we've given you a chance to do some thinking. We're going to go ahead to the next slide. And I'm going to give you a heads up that there's no volume, because often when people watch this, they're like, I can't hear it. There is no volume. So you can hum along inside your head. And Hebron, I'll get you to press play on that, please. Okay, so one of the things you may have noticed when Hebron was giving the overview earlier is that mean, median, and mode are all addressed beginning in grade 4. That is new. We used to have one each grade in the junior grades, but now in grade 4, with whole numbers, they're responsible for mean, median, and mode. And traditionally, we tend to teach mean as add up all the numbers and divide by however many numbers there are. And we want to help students make sense. Making it visual helps them make sense. So Neil, you're asking what's the difference between average and mean? Most people, when you hear them use the word average, like in lay terms, they mean mean. So they mean the mathematical average, which is taking the total and dividing among the number of values. Average, though, can mean mean, median, or mode. Average is another word for a measure of central tendency in mathematics. So in layman's terms or lay people's terms, average and mean the same thing, but within this strand of mathematics, an average might be the median, it might be the mean, it might be the mode. It's actually all of those. Those are all averages or central tendencies in the data. Okay, Hebron, can you go to the next slide, please? So now that you've seen that video and looking at this representation visually, I want you to think about how would you define mean? And I'm just going to give you a moment to think about that. How would you define it? not the algorithm, but what does mean mean? And I'm going to invite, if there's anyone who would like to share, what do you think? So Wendy is saying equal sharing, which is not mean.
Well, I meant to say which is nice, not mean.
Ah, okay, yes. And I think that's the key, is to help students understand, because junior students have an understanding of equal sharing. They know what that means, equal or fair sharing. So if they understand that that's what the term mean, that measure of central tendency means equal sharing or an equal distribution of the total across all of the values. So if you look at this slide, there's a couple of bullets about the way that you can find the mean with cubes, combining them all into a huge pile and then sharing them equally among 6 groups, or making the trains as they show in the visual and then redistributing until they're all the same length. It's really important that we help students to see this with simple numbers so that they understand why, when we get to grade 6 and we're dealing with decimals and we're dealing with large whole numbers, we're not going to make trains, but we want to start with that even in grade 6. So they have that understanding that, oh, well, if I put them all into one pile, I find the total, and then I equally share them among the number of values or the number of groups, I'm going to get the mean. I'm going to get that equal distribution or that fair sharing. So that's really important, because again, historically, we've just taught kids, add them all up and divide, and then they don't understand why. What does that mean? And so the visual here is really key. Next slide, Hebron. So yes, Rebecca, central tendency is an umbrella term for mean, median, and mode. Yes, because they tend toward the center. And actually, these graphs can help us see that. So with these graphics, the first graphic is showing the mean. There's what we would refer to as like a normal curve, a parabola. And then the dotted line is showing that equal distribution. So and then the graphic at the bottom, so the middle graphic shows median pointing to the center. And then the graphic at the bottom shows that the mode, the median, and the mean have all been calculated. Those are frequencies, but they all tend toward the center. So the central tendency is, where does the data tend to group in the middle? Hence the term central tendency. So yes, it is an umbrella term. And again, I just want to reinforce, in grade 4, students are working with mean, median, and mode, whole number values. In grade 5, the same, but with decimal values. And in grade 6, as Hebron mentioned earlier, we've added range, and we're comparing 2 or more data sets and making some arguments using the central tendency. So there's arguing about which is a better measure of central tendency, and there's also arguments about which might be a better, it wouldn't be product, what might be a more accurate representation, this set of data or this set of data, an accurate representation of a situation, and you use mean, median, and mode to help with that convincing argument. So this whole strand topic is about convincing arguments, about data, and then later about probability. So keeping those convincing arguments in mind, we're going to head on to the next slide. And I'm going to invite your participation once again. First of all, what type of graph is this? So looking at this graph, what type is it? And how is it misleading? So I'll give you some time to read, analyze, and respond. And can you show responses, please, Hebron? So we have a couple of question marks. Is it a pictograph? Is it a bar graph? Does it include the pillow? There appears to be more than 100%. What I appreciate is that you are doing some critical thinking about this data, and that's exactly what we want our students to do. There's no clear scale, so how can I be sure the parts are proportionate? Somebody's suggesting it's a histogram. Okay, so let's go back to the picture, please, Hebron. So hide response, or click hide responses again. A couple of you mentioned the idea about the pillow and the proportionality. And so that is the part of this stacked bar graph. This is a stacked bar graph, even though it's oriented differently than we often see with a stacked bar graph. It's oriented horizontally, and we often see it vertically. But this is a stacked bar graph, and it is misleading because, first of all, it's 3D. And when graphs are 3D, it distorts perspective and proportion, as one of you mentioned. The pillow also creates that added visual distortion, because if we look, like, where does the left-hand side of this graph start? Is it at the bed? Is it at the pillow? And then notice that even on the left-hand side, the bed, because of perspective, it goes on an angle. So that's what's causing some of this misleading, the pillow and the 3D nature of the stacked bar graph. In addition, if we look at luxury hotels, is like a darkish green, and it's 4%. Beside it is yellow, and that's hotels. It looks like it's significantly more than 1% more. And then homestay looks like it's the same as the yellow hotels, but it's actually 1% more. So it is really hard to tell proportions in this particular graph. We want students to ask those kinds of questions, make those same kinds of noticings that you did. Also, I'm noticing it's 1996. Private homes is likely going to be a lot different with the whole introduction of Airbnb. And then we've got the whole pandemic and how has that affected things. So there's a lot you could have conversations around this graph with students. Another question we want students to think about is who would benefit, like who might want to have a graph that's misleading. And in this case, it's hard to tell. This is New Zealand, so who produced it? International Tourist Choice of Accommodation. So that's people coming from out of the country, but who's producing this graph and what might they be trying to highlight? They may not have intentionally been misleading. They may have just been trying to make a nice pretty bed to match the topic of their data. Okay, on to the next slide, please. So there are a few ways in which graphs can be misleading, and we want students to discover these through analysis of graphs. So in both the grade 5 and grade 6 sample weeks at a glance, we have that first graph with the fruit. And it's quite apparent that because the symbols are not uniform in size, it makes it look like one category is much more than another, when in fact there were 4 in each. Since there's no legend to tell us otherwise, we're assuming it's a 1-for-1. So that's one way to be misleading, is symbols that are not uniform in size. A very common way of misleading is showing only a portion of the axis, so it doesn't start at 0. And then it can exaggerate differences. So these are the type, for example, the one that says peanut butter sales on the right. We can ask students, well, who might want to show the graph this way, and have them re-represent the data starting at 0, and they can see that, oh, brand B looks way better if I take only a portion of that scale. And then it does exaggerate, oh, brand B must be that much better. Using unequal intervals, so in the third graph, guests at a resort by age, that's a histogram. And you can see the first category is age 20 to 40. The next one is 40 to 70. And then 70 to 80. So those aren't equal intervals, and that's going to skew the data. And finally, like we talked about with the bed, having a 3D graph distorts perspective and proportions. And we see that quite often in the media with pie graphs or circle graphs that are made into 3D, and a piece pulled out can really exaggerate the size of that piece or the size of what's left, depending what the author of that graph is trying to highlight. So again, that whole idea about convincing arguments and critical thinking about data. And at that, I'm going to pass it back to Hebron.
Awesome. I'm just going to make sure you can hear me. Perfect. We are moving on to the probability concepts. We're going to start with a 3-2-1 waterfall. So a 3-2-1 waterfall is where you're going to write down your response, but do not press enter in the chat. And then we're going to watch our responses waterfall together. So what is the theoretical probability of rolling a multiple of 3 with this 20-sided die? So multiples of 3. What is the theoretical probability of rolling a multiple of 3 with this 20-sided die? Express the probability as a fraction and a percent. And if you only had time for just a fraction, we'll take that too. So we'll give you a couple minutes to think about that. Theoretical probability.
Yes, Emily.
1 to 20, yes. It's one of those Dungeons and Dragons. Classic game.
You're assuming everybody makes that connection, Hebron.
I know, I'm the only one. Board game. It's usually in board game that 3 does count, doesn't it? Right?
Well, actually, I would ask, is 3 a multiple of 3? That's what I would answer to that question, Emily.
I don't know. That's why I'm asking. I think yes, but I don't know. Some people would say no because it is 3. I don't know.
If you're counting by 3, would you count 3?
Yes.
There's your answer.
Okay, are we ready? Just one more minute. Fraction, if you have time, put it in percents. See if you can get that percentage. Ready? 3, 2, 1, waterfall. Ta-da. 6/20, 30%, almost unanimous.
Mm-hmm.
So theoretical probability. We're going to talk a little bit about what theoretical probability is and why you have calculated theoretical probability. Theoretical probability is looking at a situation, looking at the chances of that situation happening and calculating it without necessarily rolling. We haven't rolled the dice, right? So in this case, we've got multiples of 6 multiples of 3 out of 20 that have showed up. So you have 6 in 20 chance of rolling a multiple of 3. So that's completely theoretical. We're just determining the probability of this event based on the math that we calculated, right? And it is a dice, so the likelihood of any one of those rolling is equal. So it's not like rigged or something like that. So that's the idea of theoretical probability, just calculating that. Now, I do want to jump into a probability experiment that we're going to do together. So if you click on, if you have the Pear Deck, if you click on the online dice rolling app, it's a 20-sided die. What I would like you to do is you're going to roll your 20-sided die 20 times, but we're going to track all our data together in the spreadsheet that's linked there. So pop your name. If you open up, let me just show you what this looks like. So this is the 20-sided die. You're just going to click roll and it'll roll and give you a random number. So when I roll 9, I'm going to switch to that spreadsheet, put down my name. My first roll is 9. Okay. And then we're all just going to jump in there, pop in your name, pop in your rolls. You should have 20 rolls. And then we're going to come back and take a look at what we noticed. about our experimental probability because we are currently doing an experiment. Any questions?
I'm changing it so that they can edit.
Oh, yes. Thank you.
It should now be editable by anybody.
I'm actually going to conduct my experiment live while you guys do it too. How does that sound?
I can't get my dice to roll.
Oh, is it
You
just
click
glitching?
on the,
Roll.
maybe it's
Yeah,
just
click
really
on-
slow.
Yeah,
Yeah.
it could be just slow, right?
Okay.
And if you have a 20-sided die at home from your Dungeons and Dragons kit, please feel free to take that out and roll it 20 times in real life, which is always better. There's also like a little bit of a race happening in that spreadsheet. Emily's in the lead now. I was, but I'm slowing down because I'm talking too much. Okay, so if you can hear me, I'm just going to ask us to pause for a second. Would like you, I know you're not done your 20 rolls. It's okay. I'm doing it on purpose. We can just pause for a second. And if you are in the Meet, you can look at what I'm sharing, or if you're in the spreadsheet, if you scroll down to the bottom of the spreadsheet, you'll notice a table. And our table on the bottom is just adding up all the number of times we've rolled that number. Okay, so for every roll, for example, I'm in the frequency of roll of 4. We've got 6 for that, and 7 for that, for 5. So what we're going to observe is as we continue to add more of our rolls in, what might we expect? Actually, what I would like you to predict with me, what might you expect would start to happen as we continue to put in more of our experimental data into this and it's adding it all up? Oh. You expect to get 9 of each, Emily says. And Wendy put up her hand. Yes, Wendy?
I was actually thinking I forgot that we weren't actually rolling for threes. Are we rolling for, we're not rolling for, oh, I can't even think anymore.
Yeah,
Sorry.
multiples of 3?
My
No,
computer,
we're just...
my brain has stopped.
It's okay. You're not waiting for multiples of 3. You're just rolling it and recording all your rolls. Doesn't matter which one. Yeah.
So it should become closer to theoretical probability.
Interesting. And what's the probability of rolling? It should be 1 in what, if you're getting a certain number?
1 in 20, right?
Yeah, like if it's all fair, it should be 1 in 20. Now, our data is going to be limited because there's only a number of us, but we should be approaching, not going further away from that 1 in 20. So just keep an eye out on that bottom table there. We've got a lot of 9s and middles of the ground, 6, 7s, 10s. So we're going to keep rolling and see what we get at the end of this. All right. Oh, you guys are all done. Most of us. Well, no. We're about halfway. All right. I'm about halfway. I'll keep going. Oh, Emily, I'm just reading your chat.
Oh, sorry,
So
I wasn't reading either.
There's more than 9 people now, though.
I've built in. So I'll show you the formula. I've kind of built in a little piece of the formula that'll just count basically how many 6s are in that entire grid.
But I like Emily's thinking because I like to know, like, out of 180 roles, and now what if we did 360 roles? And so I
Yes.
think it's important to know the total number of roles. So I think that's a piece that I would like to see embedded in the spreadsheet, is a total number of roles somewhere.
Oh,
Like
that
a
would be nice.
cell that actually says total number of roles, maybe to the left, or to the right of the frequency column, or frequency row.
Okay. Roles. That's great. Okay.
I was just thinking, because how else do you figure out if what you have is 1/20th? Like if you don't have the total, like for frequency of 3, it's 16 out of what? So like, how do you know if that's 1/20th or not?
So for me, when I look at it, I'm just looking at, the range should be less, right? So they should be closer to the same number. The more you roll, the frequency of 1 through 20 should get closer and closer to the same number.
Can you say that again?
So for me, when you first stopped us,
Oh,
Ron, the
yeah.
lowest one was 2 and the highest one was 11.
Yeah.
Now though, when we look, the lowest I think is 6.
Yeah. 9, 7, 6. Yes.
And the highest is 16. So the range is slightly reduced. I would anticipate that the more we roll, because the theoretical is that they're all going to be exactly the same.
Yes.
Right? Theoretically, they have the exact same probability. So reducing that spread, reducing the range, would be getting closer and closer to the theoretical.
Yes. That is correct.
Like you, Neil, I was the same. I got 10s like all the time. So I was
A
skeptical.
lot of sense. What is going on?
I was thinking, like, theoretically, everyone should get every number because we're rolling 20 times. So everyone should get every number. So if everyone's supposed to get every number, then if there's 11 people playing, you should have 11 of each number. That's how I got 9 first. And then I did the math after.
Yes. So that makes perfect sense. Because what I've done in this formula, if you can see that, is it's just, it takes the whole grid, sums up every number that you've put in, and counts every time there's a 1, essentially, right? And then there's no division needed because 1 is 1. But if you have something like 2, you need to divide it by 2 here because you'll have a total that's divisible by 2. So you want to count how many 2s you got. But yes, you're correct. So you would get, if you had 11 people rolling, you should have 11 of each, and so on and so forth. And we had so far 10, 1, 2, 3, 4, 13 of us rolling. So we are sitting around 13. And what might give us more data is if we took the frequencies of each and found the average, and if it was near the number of people we had, right? So it gets complicated when we get bogged up right in all the details of the math. But the big picture is experimental data doesn't always land in the theoretical realm. But as you get bigger and bigger amounts of experimental data, you get closer and closer to the theoretical value. So when you do this with a class, what you would focus on is, hey, let's pause at a certain point, maybe like halfway or a little bit before halfway, maybe even a quarter of the way through rolling. Let's all pause, see what we have. And let's pause it halfway and see what we have. Are we getting, what are we approaching? And then let's keep going to the end of however many rolls we want to do, or whatever probability experiment you want to engage in, and then see what happens. And what we want to observe is the trend getting closer to the theoretical value. And then if you're like, well, I guess if we had like 30,000 people rolling 20 times or 100,000 people rolling 20 times, then things would get even closer to that theoretical value. Awesome. Anything else you want to add?
Not me.
Cool. Yes, and so I tried. The problem, I am going to have to do a total number of rolls. I'm going to do it in that. We want you guys to be able to take this. Oh, I should do it right now before I forget. Oops. B26 to U26. We want you guys to take this and be able to use it with your class, make your own copy. So we've had 226 rolls altogether. It's just summed up all those. And use it as you like. You can augment it to use for different experiments. It's just kind of a handy way of gathering data together with your class. All right. So probability, this is what it looks like. We kind of talked about this a little bit. In grade 4, it's very descriptive on a probability line, dealing with the likelihood of something happening. For sure, 100%, impossible, and everything, even in between, and everything describers likely and unlikely between. In grade 5, we're getting into theoretical and experimental, kind of defining what those two mean. I think there's experiences where we've done a lot of experimental probabilities in the games we play, but working out the chances mathematically is the theoretical side of things that maybe students might not have as much experience with, and we just identify it and label it for them through some experiments that we do together. Grade 6, we're comparing theoretical and experimental probabilities of two independent events happening. So that idea of comparing two sets of data comes into play with experimental and theoretical. We've done things where we've compared probabilities in things that we think might be connected or might be completely disconnected in trying to assess that. So likelihood of being able to juggle this much based on the size of your hands or something like that, where you can create experiments and you measuring two different things as opposed to just the one that we did right now, which is rolling to 20.
Just a simple example of that I've done in the past is just roll a die and flip a coin.
Yeah.
So what is the theoretical probability of getting a 4 or an even number in a head? And figuring out that theoretically with all the possible outcomes, like a tree diagram, and then actually doing the experimental and seeing that, no, you're not going to get the theoretical. But like you want two simple independent events, and it just means independent. So it's not like in grade 7, they then do dependent events. So I have a bag of marbles, I take one out and I put it back. That's independent. If I take it out and I leave it out, that's dependent because now the odds have changed because I've taken it out and left it out. So that's what it means by independent events there. It's not when I roll a coin, or no, when I roll a die, what I get does not influence my next roll. If I flip a coin, when I flip the next time, the previous roll does not influence. It's not dependent on what I got before. Where drawing a card and keeping the card out of a deck, that does influence the odds of me getting whatever card I'm looking for the next time. So I just want to clarify what it meant by two independent events. It's independent of each other.
Yeah. And that it's important because it gets much more complicated when they're dependent.
Yes.
All right. So that we are about 2 minutes over time here. These are the sample weeks at a glance for grade 4, 5, and 6. For the sake of time, I'm not going to go through, open them up. They're available for you, and we'd like a little bit of feedback, as we always do, something that you're taking away from the session, one thing, and pop that into that text slide. And then if we have any questions, stick around, we can address your questions. Just a heads up, we are getting back together June 1st 4 to 5 again, just to look at some consolidation engagement resources together, as well as look at how you might do consolidation time with your classroom. Awesome.
There is not, Emily. So we focused on making convincing arguments because people in general are more familiar with probability. And we have linked to the additional problems pages. And there are quite a few probability experiment questions or tasks that you can do from the LRP site, from the additional problems page. So we're only giving the one the first week where we focused on data to really emphasize the making convincing arguments. And also we're recommending at the bottom of each week at a glance to use mean, median, and mode. So that data that we just collected, we could look at our experimental data now and we could find, well, what was the mean number of roles and what was the median and what was the mode, like which one came up the most. And so using those measures of central tendency with your probability experiments. Any other questions that people have at this point? So please do provide your feedback in the Pear Deck. And if you don't have any more questions, thank you so much for your time, for spending the time with us. And feel free to reach out if you do have questions. In the meantime, enjoy this wonderful warm weather week, finally.